Hello all, welcome to Gurudev Science College, Dharwad. In the today's session, we will be discussing a model question paper of mathematics from a different district. So let's begin with the questions. The first question is on finding whether the given relation is a symmetric relation or not. So let's begin with the questionnaire. First question is, a relation R defined on the set A. Set A is given, that is 1, 2, 3, and a relation R is defined on set A. Relation R is defined on set A, that is 1, 1, 1, 2 and 3, 3. Now you have to check whether this relation is symmetric relation or not, right? So let us recall the definition of symmetric relation. Yes, how you define symmetric relation? If A comma B belongs to the relation R, then B comma A must belongs to R. Then we say that the relation is symmetric relation. But if you observe this particular case, in the defined relation, here 1, 2 belongs to R, but 2, 1 does not belongs to R. Hence R is not symmetric. R is not symmetric. Right? It will be easy to understand why it is not a symmetric relation. Let's go for the second question. The second question is on the definition of binary operation. Define binary operation. Define binary operation. Right? So what do you mean by binary operation? As its name itself defines, binary means minimum 2 variables are required here. Therefore, let us consider a relation defined. Say we are defining star as a binary operation, which you are going to define from, right? You need a domain. What is the domain in this case? A cross A. And you need a range. What is the range? A set A itself. It means what? Let A be non-empty set. Let A be non-empty set defined such that star from A cross A to A is called binary operation. Is called binary operation. Right? It is also denoted by, how you denote this binary operation? Observe here, we have Cartesian product here. Therefore, input must be in the form of an ordered pair, that is star of A comma B, or even you can also define it in the form of A star B. Okay. So notice here, star is nothing but a relation which you are going to define from Cartesian product to a set. Okay. You have to define it on the same set. So that is how you define binary operation. So let's go for the third question. Find the principal value of cos inverse of minus 1 by 2. The third question is on inverse trigonometric function. Find the principal value of cos inverse of minus 1 by 2. Right. So we have studied a set of relations in inverse trigonometric functions regarding their domains and range. Right. So surely we will get one question on that part. Now here we have particular examples for finding the principal value, right? So we know that cos inverse of minus x is always equal to pi minus cos inverse of x, isn't it? So using this identity, let me define cos inverse of minus 1 by 2 can be written as pi minus cos inverse of 1 by 2. So we have pi minus cos of which angle is 1 by 2, that is 60 degree. So that becomes pi by 3. Hence, what is your answer? 2 pi by 3. Isn't it? Sine 30 degrees 1 by 2. Hence, cos 60 must be 1 by 2. So, this is how you calculate the principal value for the given function. Right. So, next, fourth question. Again, it's on the inverse trigonometry function only. Find the value of cos of secant inverse x plus cosecant inverse x such that mod of x is greater than or equal to 1. So, again you can remember it follows a standard form of inverse trigonometric function identity, right? Do you remember? Sin inverse x plus cos inverse x for defined x value, this answer is always equal to pi by 2. Hence, it follows for the secant inverse x plus cosecant inverse x too. Therefore, what is my answer in this case? Cos of pi by 2. What is cos of pi by 2? Is nothing but 0, isn't it? So, cos pi by 2 is 0. Let us go for next question. If a matrix has 8 elements, what are the possible orders it can have? The question is on the matrix, right? There is a matrix say of order m cross n, and now what he is telling, this matrix has 8 elements. 8 elements means what? M cross n is equal to 8, right? So, what will be the possible orders it can have? So, I think we are interested in multiples of 8, right? Factors of 8. So, what is my answer? 1 into 8, right? 2 into 4, then 4 into 2, then 8 into 1. Just take care of the factors of 8, right? Whereas 1 into 8 and 8 into 1 are two different cases. Why? Because first element denotes number of rows, second element denotes here number of columns, right? Hence, 1 cross 8 is different from 8 cross 1 in matrices, right? So, let us go for the sixth question. Find the value of x if the given determinants are equal to 4, 5, 1 must be is equal to 2x, 4, 6, x. So, dear students, please notice if you are not properly observing these standard presentation of determinant, you might think it as a matrices. Okay, please take care of these vertical lines properly. Fine. So, as it question is on the determinant, you just take care of solving or expanding the determinant, right? So, butterfly method. So, how you consider the LHS part? Therefore, what is the LHS determinant value? 2 1s are 2 minus 4 5s are 20. Similarly, in the RHS what we have? 2x into x is 2x square minus 6 into 4 is 24. Now, it is all about simplification. So, we have what we have in the LHS, minus 18 is equal to 2x square minus 24, or is it 2x square is equal to, take minus 24 to the LHS, that become plus 24. Plus 24 means we will be getting 6, or is it x square is equal to 3, isn't it? Therefore, what should be the value of x? It must be equal to plus or minus root 3. Why should you consider plus or minus? Because x square we have, x square always defines a quadratic equation. So, it is compulsory to have both the signs, plus as well as minus. Clear? Right. So, let us go for the next question. Differentiate. The next question is on the differentiation. Differentiate, say let me consider y is equal to log of cos of e to the power x with respect to x is the given question. So, you have to differentiate the given function with respect to x. Means what? We are trying to find dy by dx, right? So, I hope you remember the identity in this case. Which identity it follows? Log f of x, that is composite function, or even you can call it as chain differentiation, right? So if you recall the identity, what is the differentiation of log f of x? What is the differentiation of log f of x? The differentiation of log f of x is f dash of x divided by f of x, isn't it? That is 1 by f of x into f dash of x. Similarly, what will be log cos of e raised to x here? 1 divided by cos of e to the power x into minus sin e to the power x, which is a differentiation of cos e to the power x. Means you are following which identity? Cos f of x identity. What is cos f of x identity? Differentiation minus sin f of x into f dash of x is the result, correct? Therefore, we have minus sin f of x into, what is f of x differentiation? Is nothing but e to the power x. So if you observe carefully, we have minus sin by cos. So that becomes minus sin by cos is what? Tan e to the power x into e to the power x. That becomes a differentiation of given log cos e to the power x, right? So just try to understand, it is a chain differentiation problem. You are trying to differentiate it as log one function, cos second function, e to the power x third function. It has got composite functions, right? So first we are using log formula, then we are using cos formula, then we are using e to the power x formula. Hence the chain differentiation retains as minus tan e to the power x into e to the power x. Let us go for the next question. The next question is, if y is equal to tan of 2x plus 3, y is equal to tan of 2x plus 3, then find dy by dx. Once again we have derivative. So it follows which identity? Tan f of x identity. What is differentiation of tan f of x? Secant square f of x into differentiation of f of x. That is differentiation of 2x plus 3. What is differentiation of 2x plus 3? Is absolutely 2, because differentiation of constant is 0. So how will you finalize this result? 2 secant square 2x plus 3 is the result. Clear? Here. So simple question. Once again, here we have chain differentiation. Okay. Next. The ninth question is on integration. Evaluate integration of cosecant square x by 2 dx. Cosecant square x by 2 dx. Of course, you can make it very simple by substituting x by 2 is equal to t. That is one method. What is another method? Let us recall. We know that if y is equal to cot x, what is y dash is equal to? Minus cosecant square x. Clear? What is the differentiation of cot x? Minus cosecant square x, isn't it? Don't you think it follows the same method? We have got cosecant square x by 2. You can solve it in one line solution. Yes? How will you solve this question? If you observe carefully, suppose if I am having cosecant square x, my answer would be directly cot x, right? But we don't have minus here. Therefore, what will be my answer? Minus of cot x. In place of x, we have x by 2. Cot of x by 2 whole divided by x by 2 coefficient is 1 by 2. Therefore, the integral of cosecant square x by 2 dx answer is minus cot x by 2 divided by 1 by 2. You can take this 1 by 2 to the numerator also. Or else, if you want in detail solution, let's go for substitution. Put x by 2 is equal to t. Clear? So what we get? 1 by 2 dx is equal to dt, or dx by dt is equal to 1, or you can take dt by dx also, whichever is fine. Okay, so however I am interested in dx value. Therefore, what is the dx value? Dx value is nothing but 2 times of dt. Now substitute here that I will be cosecant square t, and what is dx? That becomes 2 times of dt, right? So 2 is a numerical constant, keep it outside the function. What is left within the integral part? Cosecant square t dt, which is nothing but the standard form, right? So what will be derivative of this function? Minus cot t plus c. Therefore, what is your answer? Minus 2 cot t. T means what? X by 2 plus c, right? If you are perfect in the basics of integration, you can solve it in one line solution, or if you want in detail solution, just take care of the substitution method and how you change the variable from x to t, right? So both the ways are accepted. Let's go for next question. Find integral of 2 to 3 1 by x dx. It is on definite integrals. Find integral of 2 to 3 1 by x dx, right? So what is integration of 1 by x? We know that log mod x plus c, but as it is definite integral, we are not taking plus c. Let me go for just substituting the upper limit and lower limit. So what will be the answer? Log mod 3 is nothing but 3, log mod 2 is nothing but 2. This is in the form of log m minus n. Therefore, what should be your answer? Log m by n. That should be your answer. That is log 3 by 2 is the right answer. Clear? Clear. Next. The 11th question is on vectors. Define co-initial vectors. Define co-initial vectors. Define co-initial vectors, right? So for which vectors you call it as co-initial vectors, right? The meaning of this co-initial itself lies in the word co-initial. Means what? 2 or more vectors, 2 or more vectors are said to be or called co-initial vectors. Co-initial vectors if they have same initial point. If they have same initial point. Same initial point means what? Let us consider this is an initial point. So you can observe we have vector A, vector B, vector C, vector D and vector E. For all these vectors, initial point is same, isn't it? So such type of vectors are called as co-initial vectors. Similarly, we have co-terminal vectors, isn't it? What do you mean by co-terminal vectors? All vectors go and coincide with the same end point, isn't it? Ella vectors ಬಂದು ಏನಾಗ್ತಾವ್ರಿ ಒಂದ ಪಾಯಿಂಟ್ ಮೀಟ್ ಆಗ್ತಾವ ನೋಡ್ರಿ. They are called as co-terminal vectors. They will meet on the same point, right? Fine. So however, you should concentrate on the definitions of different vectors. There are collinear vectors are there, right? Please take care of the definitions on the vectors. Surely you will get one question on that. Let's go for the next question. The most important concept from vectors once again. Find the unit vector in the direction of a given vector. Yes, they have given a vector that is A, which is I plus 2j plus 3k. You have to find a unit vector in the direction of given vector, right? So you know what do you mean by unit vector? What do you mean by unit vector? the magnitude is 1, correct? That is one part. How better you can understand? You take any vector, divide it by its own magnitude, right? So what is I coefficient? 1 square, j coefficient 2 square, k coefficient 3 square. So that becomes 9 plus 10 plus 4, that becomes root 14, right? So you can convert any vector to unit vector by dividing that vector by its own magnitude, right? So divide it by its own magnitude, then that becomes unit vector of any given vector. You take any vector, right? So it's all about dividing it by its own magnitude. This is very, very important. Clear? So we call it as a unit vector. Next question. Write the direction cosines of z axis. Write the direction cosines of z axis. Right. One of the beautiful question on the 3-dimensional geometry. Right. So we all know that in the 3-dimensional space, if you just observe the 3 axes, x axis, and let me define the y axis and z axis, correct? So when you just try to recall, right, let me call it as x axis, y axis, z axis, and where they meet is origin. So we have studied about the basic unit vectors on the axis. What do you mean by basic unit vectors? Suppose if I take any point on the axis, it will have the possible direction ratios 1, 0, 0, and this is along y axis 0, 1, 0, and along z axis we have 0, 0, 1, right, which is nothing but in the form of x comma y comma z. Please observe, the direction ratios are defined as, I am talking about direction ratios of z axis. What will be the direction ratios? That becomes 0, 0, 1. Now let me define direction cosines, right? How will you calculate direction cosines? X divided by the magnitude of the given vector, right? So what is the magnitude of given vector? Square root of 0 square plus 0 square plus 1 square, that becomes 1, isn't it? 0 divided by 1 is also 0, 0 divided by 1 is also 0, 1 divided by 1 is also 1, isn't it? 1 divided by 1 becomes 1. Therefore, direction ratio and direction cosines, understand the difference. What makes the difference? The most important concepts, direction ratios are nothing but numbers and direction cosines are also nothing but numbers, but there is a difference here. What is the difference? In case of direction cosines, the sum of the squares of these values is always equal to 1. Sum of the squares of these values must be equal to 1, isn't it? So how you denote direction ratios? Actually, x comma y comma z, we denote it as direction ratios, whereas direction cosines are defined as L, M, N, where what is L is equal to? L is equal to x divided by root of x square plus y square plus z square. What is M is equal to y divided by root of x square plus y square plus z square. So just take care how it will make a difference. What do you mean by direction ratios? What do you mean by direction cosines? Right? Okay. Let's go for the next question. The next question is, define optimal solution. Define optimal solution. Optimal solution. The question is from the LPP, linear programming problems. So what do you mean by optimal solution? Optimal means what? Optimum means what? Which has to be maximized or minimizing a function, right? So this is nothing but a solution from feasible reason in which objective function has to be minimized or maximized. Is called optimal solution. Is called optimal solution, isn't it? I have already practiced many questions on this. When you define the objective function, that is z is equal to, right? So you are using z is equal to as an objective function, isn't it? Z equal to ax plus by. This function either will have maximum or will have minimum, or it can have both the cases, maximum as well as minimum, right? So how you are going to define this? You are going to define it in the feasible reason, right? In that we call, say at any given point, of course there are different points. At any particular point it will give you maximum value, at any particular point it will give you minimum value, right? So they are also called as optimal solutions, right? So how you define a solution from feasible reason in which objective function has to be minimized or maximized. So such solutions are called as optimal solutions. Clear? The next question, 15th question on the probability, right? If P of A is equal to 0.8, P of B is equal to 0.5, then find P of A intersection B. If A and B are independent events, right? I hope you remember, if A and B are independent events, what happens to P of A intersection B? Independent events ಅಂದ್ರೆ ಯಾವುದು ಕಂತಿವೇಡ್ರಿ? If occurrence of one event is not affected by the occurrence of another event, isn't it? So P of A intersection B is always equal to P of A into P of B, right? Therefore such kind of two events are called as independent events. Therefore what is P of A? 0.8. What is P of B? 0.5. So that becomes 8 by 10 into 5 by 10. So what will we get? 40 by 100. So what will be your answer? 0.40 is the required answer. Following. So always try to understand independent events. Independent event means this is the definition of independent events. You can even extend it for any n number of events. If you have P of A intersection B intersection C, if it is equals to P of A into P of B into P of C, then we call them as ABC are the independent events, right? So this is purely a set of first 15 1 mark questions which we have discussed now, right? The next session will be discussing on the 2 marks questions, right? I hope you can just revive all the concepts from our small effort, and definitely it will boost up your confidence. So please take care that you will be parallelly taking care of the solutions as well as concepts when you are trying to view our videos, right? Thanks for watching Gurudev Academy. Thank you everyone.